a question can come, they can give you a battery there, okay, and then they can put for you two resistors. One is there, the other one is down here, okay, and then this one can be 2 ohm resistor, this one can be 4 ohm resistor, and then this one can be 12 volts, the battery. And then the first question can come as calculate the effective resistance. Okay, calculate the effective resistance. You remember what I said concerning effective resistance? I said you always put 1 over RT, and then you ask yourself how many resistors are present in the diagram. If you look at the diagram, there are 2. There is 2 and 4 ohm. So it means I'll put 1 over resistor 1 plus 1 over resistor 2. If the resistors were 3, it would be 1 plus 1 over resistor 3. If there are 4 plus 1 over resistor 4. So according to the number of resistors, that's how you are going to write. But always at the beginning, make sure you put this one 1 over RT. Always at the beginning, 1 over RT is always going to be there. 1 over RT, you always put it at the beginning. Never forget it. So 1 over RT is equal to 1 over R1. So this is 1 over RT. Always you put this one at the beginning. I think that's clear. So 1 over RT is equal to 1 over R1. What is the resistor 1? From the diagram, it is 2 plus, because that's 1 on top. 1 over resistor 2 is what? 4. You see? Which resistors are these? This is the resistor 1. This is the resistor 2. Okay? So 1 over resistor 1 is 2. 1 over resistor 2 is 4. Okay? These are the resistor 1 and resistor 2. Okay? I think I've already explained this in the latter part. So 1 over RT is going to be equal to 1 over 2 plus 1 over 4. When you reach here, you always look for the common denominator. I think you learned this in grade 4. That's the only way you can solve this fraction. Common denominator is 4 there. 2 into 4, 2 plus 4 into 4, 1 plus 1 on top there, 1. Okay? Then you add. So 1 over RT is equal to 3 over 4. Again, 1 over RT is equal to 3 over 4. When you reach there, you cross multiply. You remember this. So 3 times RT is going to be 3 RT is going to be equal to 4. Divide by 3, divide by 3. RT is going to be equal to 1.33 and so on. That will be RT, which is ohms. Okay, since it's resistance. That can be your question 1. Your question 2 can be, which is question B, calculate the current in the 2 ohm resistor. Okay? Calculate the current in the 2 ohm resistor. When they give you such a question, you remember when they give you such a question, what do? You always use this formula for finding current. Resistance is equal to voltage over current. So if I'm finding current, I'll highlight current here. Current is what I'm finding. So what current is I here? So resistance is equal to voltage over current. So which one is not in red? Current is equal to, you see, voltage on top over resistance. So current in resistor, the question was saying current in 2 ohm resistor. So it means on resistors I have to put 2 ohm on resistor. So voltage is equal to what? So current is equal to voltage over resistance according to this formula. What is the voltage? 12. Resistance, they said the resistance in, the current in resistor 2. So meaning on resistor I have to put 2. So there is equal to 6 amps. Okay, this voltage here, don't get confused. I've got it from the diagram. Okay, the voltage was given from the diagram. Is this one, 12 volts over 2V, or over 2 ohm here. Listen, resistance equal to voltage on top, 12 divided by current, which is 2 here. That's what the formula says. Okay, that's how you do it. So you get this current is equal to voltage over resistance. The voltage is given 12 volts. The resistance, they said, in the 2 ohm resistor. Okay, and then C, question C, that was question B. calculate the current in the 4 ohm resistor. You see there are two resistors now in the 4 ohm. It's the same thing. You always use the same formula. You get the formula from this. Resistance is equal to voltage over current. When I highlight current here, current I highlight it. What formula do I remain with? Once the current is there, voltage will remain over the resistance. So what do I have? Current is equal to, what's my voltage? 12. The resistance is what according to this formula? The resistance that was given in the question, current in the 4 ohm resistor. So it means on resistance I have to put what? 4. And then 4 into 12, it is 3. 3 what? 3 amps. And that's how you solve this. Basically, that's how you solve this type of questions. However, I'm repeating, this is how you solve this question. We have ended. But this question only works when they give you such kind of resistors, where there are 2 resistors in parallel. I repeat, this formula will only work well like this when there are 2 resistors like this in parallel. Okay? If we introduced a third resistor here, maybe put another resistor here. Okay? When we put another resistor here, the calculation will be different. Okay? If we introduce a resistor here, if we had introduced a resistor here, okay? If for example here I put another resistor here, maybe I name it 2 or 3 amps. I mean 3 ohms. The way we would have solved this question is different. Okay? Because there are 3 resistors. But the way we have solved that one, it was only both of them in parallel. But once I put a third one here, it means the resistance in parallel and also resistance in series. But we're not dealing with this. We'll deal with this type of question on the next part of the exercise. The next part of the lecture, I mean. So, we are just dealing with 2 resistors now. Okay? There would be 3 resistors in parallel. We solve them same. Okay? But in series is different. Okay? If they're in parallel, you know how to solve. So that's how you solve, guys.